T minus 1 minute. T minus 50 seconds. T minus 40 seconds. T minus 30 seconds. T minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. 0.
Good day, my fellow future engineers. Welcome to the STI West Negros University Virtual Senior High School Training Program. To formally introduce myself, I am Ana Delia Pauline Felicissimo, a third-year Bachelor of Science in Electrical Engineering student. They say engineers are the ones who love to make and to solve problems. Others would say you need to be smart in order to become an engineer. But the truth is, if you have a willing heart, a dream, and a passion in engineering, you will become an engineer. Today is the day where we gather all of you, our aspiring engineers, to know, to understand, and to learn, and to observe how engineers become engineers. And also, what are the things, adventure you need to take in order to reach your dreams? But before we start, let us first ask guidance from our Father in Heaven through this prayer that to be followed by the national anthem and the STI hymn.
Hide me now under your wings. Cover me within your mighty hands. When the oceans rise and thunders roar, I will soar with you above the storm. Father, you are king over the flood, and I will be still, know you are God. Find rest, my soul, in Christ alone. Know His power in quietness and trust. When the oceans rise and thunders roar, I will soar with you above the storm. Father, you are king over the flood, and I will be still, know you are God. When the oceans rise with you above the storm. Father, you are King over the flood, and I will be still, know you are God.
Yes, let's all aim high for our dreams to become a engineer someday. And this moment, to give her welcome remarks, let us all welcome the ever beautiful Dean of the College of Engineering, Engineer Erlyn May Hitino Desamparado.
Good morning, everyone. First of all, I would like to express my thanks to the principal of the school attending in today's immersion, training and immersion coordinator for accepting our proposal to deliver this virtual immersion program. The work immersion program is one of the course requirements for graduation. As a senior high school student, you have to undergo work immersion in a business organization and or establishment with work requirements related to the specialization. Through work immersion, you will be able to expose to and be familiar with the work environment related to your field of specialization. And specifically, you will be able to, number one, appreciate the importance and application of the principles and theories learned in school. Number two, enhance your technical knowledge and skills. Number three, enrich your skills in communications and human relations. Number four, develop good work habits, attitudes, appreciations, and respect for work. The pandemic brings us difficulties in implementing these work immersion program, considering the health and safety protocols that the government would like us to follow and observe. However, this is not the reason for us to stop in achieving our goals for education and training. Thus, STI, West Negros University College of Engineering offer this virtual immersion training program to senior high school in Bacolod City and Negros Occidental to somehow help them not just to complete their academic requirements for graduation, but to enhance their acquired knowledge and skills in their respective fields and for them to be able to be ready for their college education. To all our immersion participants, welcome, good luck, and may you enjoy this virtual immersion program, and may this would help you develop your potential in your chosen fields. Thank you everyone, and aim high.
Okay, so thank you very much, Dean Arlene. I know some of you are excited, especially in learning new things. But before that, let us also hear some words of encouragement from the advisor of the Engineering Student Council for this batch 2020-2021 and the program head of the Bachelor of Science in Mechanical Engineering, no other than Engineer Juscoro Marañon.
Good morning, future engineers of the Philippines and of the world. I would like to share with you that the engineering profession is one of the best profession. I will give you 5 reasons why. First, because this profession is considered to be one of the sought after professions before, now, and in the future. So it is in demand. Second is this profession, the engineering profession, has a good compensation. And thirdly, we can apply what the learnings from the profession in real life experiences, even at home or in the community. Fourthly, the engineering profession is a profession that is at the forefront in nation building. And fifthly, it is a profession where we can enjoy the practice of his of profession because it is not boring. And also, I will give you 5 reasons why uh, STIWNU can offer you a good engineering uh, education. First is we have the faculty who have the academic qualifications. Our faculty are very much qualified academically. We have masters and doctoral degree holders. Second is our faculty members are practicing engineers. So they can share what they have learned not only in books but more importantly in practice. Thirdly, STIWNU College of Engineering can prepare you holistically. So we not only prepare you mentally but also socially, emotionally, intellectually. So it is a holistic approach of the institution. Fourthly, the university prepares you not only for an engineering career, but also for eternity. So we are preparing you not only for a life after graduation, but also for a life in eternity. And lastly, the university has alumni who are in strategic positions at the present. in the public and private sectors, which can help you in whatever you need in your career in the future. Join our engineering family. Let us help you realize your dreams. God bless you, future engineers.
Okay, so thank you very much, Sir Marañon. Or I mean, Engineer Marañon. I know every one of us here listening today are aiming for that engineer thing title before our name, right? And why not let's work for it and start it today? Okay, so at this juncture, we would like to remind our participants that if you have any questions and or clarification, just leave it in a comment section below. And the College of Engineering team will try their best to reply those questions. So, likewise, assessment and handouts will be given to you after today's activity and for the next day's activity. Okay, so let's start. Now, I know some of you are fond of um, fixing electrical wirings, um, equipments, appliances, and even designing electrical layouts for your floor plans for fun. And to feed our minds with that information about electrical engineering, let's all hear it from our first lecture.
Good day, everyone. I am Glorian C. Gavieta, currently a second year electrical engineering student of STI West Negros University. So, are you curious about electrical engineering? Or do you have questions like what does an electrical engineer do? Or what are the areas covered by this field? So, don't worry because today we are going to share some information and ideas about the field electrical engineering. So, let's start. So, first of all, let's define what is electrical engineering. So, electrical engineering deals with the design, operation and protection, maintenance and economics of electrical equipment and electrical systems with emphasis on the ethical values to harness economically and safely the materials and forces of nature or the benefit of society and the environment. So now let's proceed to the fundamental subjects when we study electrical engineering. So the fundamental subjects of electrical engineering usually includes college algebra, advanced algebra, trigonometry, analytical geometry, calculus, that would be differential calculus and integral calculus, general chemistry and physics subjects, and also general engineering subjects like statics, dynamics, strength of materials, fluid mechanics, thermodynamics, engineering management, computer fundamentals, and programming. And here are more major subjects in electrical engineering. So we have electrical circuits, electromagnetics, electrical equipment operation and design, principles of communication, alternating current and direct current machinery system design, transformer and AC apparatuses, electrical transportation and distribution, and also power plant engineering. Okay, so now let's talk about what do electrical engineers do, or what are the job duties of an electrical engineer. So first of all, electrical engineers design, develop, test, and manage the manufacturing of electrical equipment from electric motors and navigation systems to the power generation equipment and the electrical components of vehicles and personal devices. Electrical engineers' job duties may also require evaluating electrical systems, products, components, and applications, designing and conducting research programs, applying knowledge of electricity and materials, confirming systems and components capabilities by designing testing methods and properties, developing electrical products by studying customer requirements, and also researching and testing manufacturing and assembly methods and materials.
Okay, so good morning, everyone. First of all, I would like to introduce myself. I am Anadalia Polina Felicissima, a graduate of Bachelor of Science in Engineering Technology last 2019 and a graduate of Electrical Engineering Technology last 2018 from TUP Visayas and a procedure and currently a third year electrical engineering student here in STI West Negros University. So today I am tasked to discuss and share to you some of the additional information about electrical engineering. So let's start. As what we all hear from Gloria and Gavieta, it is also electrical engineering job and duties that may require the following. Developing manufacturing processes by designing and modifying equipment, assuring product quality by designing electrical testing methods, testing finished products and system capabilities, preparing product reports by collecting, analyzing, and summarizing information and trends, providing engineering information by answering questions and requests, maintaining product and company reputation by complying with federal and state regulations, and maintaining product database by writing computer programs and entering data. So overall, an electrical engineers are the one who design a specific equipments like transformers, motors, and other machines that relates to electrical technology. And as what we all know, electrical engineers are known for designing an electrical layout of a commercial buildings and residential buildings. And also, electrical engineers are known to be the guide of an electrical practitioners nga known sa aton as mga electricians, and they're the one who correct their mistakes, and also nagalearn man sila sa mga electrician, especially mga experienced now when it comes to the field of electrical technology. So the next is that electrical engineers work on a variety of projects such as computers, robots, cell phones, cards, radars, navigation systems, wiring, and lighting in buildings, and other kinds of electrical systems. So here are the subdisciplines of an electrical engineer. First, we have electronic design. This focuses on the assembly of basic electronic components to accomplish essential and complex tasks. This field of specialization can range from the creation of simple designs to the construction of more advanced circuits. Next, we have control systems. It focuses on the modeling of a diverse range of dynamic systems and the designs of controllers that will cause these systems to behave in the desired manner. To implement such controllers, electrical engineers may use electronic circuits, digital signal processors, microcontrollers, and programmable logic controllers, or PLCs. As an electrical engineer, it is also their field. Nga example, design sang isa ka system nga gusto nila automatic. Pwede sila kagamit sang PLC nga naga-operate sa mga machines nga example mga sensor nga ara pwede na makontrol gamit ang programmable logic controllers. Next is the power engineering. It deals with the generation, transmission, and distribution of electricity as well as the design of a range of related devices. These include transformers, electric generators, electric motors, high voltage engineering, and power electronics. Mostly, you can find electrical engineers sa mga distribution systems like what we have here in Negros, Negros Occidental, the three major distribution of electricity, the Noneco from the south, Noseco from the south, Seneco here in Bacolod, and in the north part of Negros Occidental, we have the Noneco. They are the one who distribute electricity sa mga balay, commercial buildings, kag sila na ang naga-operate sa mga substation, kag sila na ang mga electrical engineers na ang ara. So next, we have microelectronics. It deals with the design and fabrication of very small electronic circuit components for the use in an integrated circuit or sometimes for use on their own as a general electronic component. Some specific examples of microelectronic components are capacitors, transistors, resistors, microchips, inductors, and diodes. Sa microelectronics naman, amo na siya ang mga design nga ginahimo sa mga electrical engineers para mas maggamay, for example, sa mga IC. Hindi na makita ang mga dalagko nga mga capacitor, transistors, kay ara na siya sa microelectronics. And that duty is one of the subdisciplines of an electrical engineer. So I think that would be all for today. I hope you have learned something about electrical engineering. And see you when time comes nga magsulod ka mo sa electrical engineering. Okay, so thank you very much to our first lecturer for today. So now, how have you ever wondered how does your electric motor at home works? Or what are the components of your electric motor? And how it is controlled? Okay, so to answer that, let's continue the discussion and learn something about the basic motor controls.
Good day everyone, so today I'm going to present electric motors and basic motor controls. Introduction to motor control devices. Relays, contactors, and starter pass power to the motor by closing sets of contacts. Contacts controlled by the coils in the control circuit. Starting relays are the only active circuit for a short period of time. The type of motor control used is determined by the size and application of the motor used. So I'm going to show you how motor control devices works. Okay, motor amperages. Running load amperage, similar to full load amperage. Amperage drawn by the motor while operating. Lock rotor amperage. Amperage drawn by the motor on startup. 5 to 7 times greater than running load amperage or full load amperage. Both lock rotor amperage and running load amperage must be considered when choosing a control device. The relay uses a magnetic coil to open or close one or more sets of electric contacts. Relays are not repaired, replaced on failure. Used for light-duty applications, can be used as pilot-duty relay. The relay contacts must be able to handle the amperage draw of the load being controlled. This is a normally open contacts. As you can see, there's coil and normally closed contacts. The contactor, larger version of the relay, has movable and stationary contacts. Holding coils are rated at different voltages, can have one or more sets of contacts. Some are equipped with auxiliary contacts. Contacts and coils can be replaced. Use the exact replacement whenever possible. So, okay, the holding coil, stationary contacts, movable contacts and armature, coil connections. When the coil is energized, the contacts are pulled closed. Okay. Motor starters. Contactor equipped with overload protection. Coils, contacts, and heaters can be replaced. Contacts become pitted over time. Pitting increases the resistance across the contacts. The voltage across the contacts will increase. The voltage across a good set of contacts should be about 0 volts. So this is the clean contact and dirty pitted contact. Motor protection. Motors are expensive and must be protected. Fuses and circuit breakers protect the entire circuit, not the individual circuit components. Motors can operate under overcurrent condition for a short period of time. Most small motors have no overload protection. The larger the motor, the more elaborate the method of motor protection should be. Motor protection can be inherent, external, or external. Fuses protect the entire circuit, not the individual components. Inherent internal motor protection. Internal thermal overloads, usually embedded with the motor windings, open on a rise in temperature, thermally activated by metal snap disc, positioned so that the contact is made between the bimetal control and the motor. Snap action opens contact if the motor temperature rises above the desired level. External motor protection. Device that pass power to the holding coil of the starter or contactor. Device is open when an overcurrent condition exists. The trip point and the type of overload protector are determined by the manufacturer. The overload device takes the service factor of the motor into consideration. National Electric Code (NEC) standards set standards for electrical installation, conductor sizes, and capacities. Cable materials and applications, electrical devices, set standard for motor overload protection. The published code book should be consulted if questions are considered or encountered on the job. There are two basic designs of motor control equipment, NEMA and IEC. NEMA, National Electrical Manufacturers Association. NEMA is a trade association for manufacturers of electrical equipment and supplies. NEMA standards specify motor horsepower (HP) ratings, need motor frame sizes and dimensions, motor torques, motor starter size ratings, and enclosure specification. NEMA-rated products are typically heavy-duty, can be used in a broad range of applications, and some starters can be maintained and repaired. For these reasons, they are often more expensive than IEC motor starters. NEMA-rated motors and motor controllers are the type of most commonly used in North America. IEC, International Electrotechnical Commission. IEC is an international standards organization. IEC motor starters are often less expensive, smaller in size, are tailored for specific motor performance requirements, and the selection of the right starter for each application is very important. IEC-rated motor controllers are widely used in Europe and Asia. Temperature sensing devices, bimetal elements. Devices called heaters wired in series with a load. The heater exposes the current draw of the load. The bimetal warps and open when it gets too warm. The open bimetal de-energizes the starter holding coil. Solder butt. Uses solder with a low melting point. The solder melts when excessive temperature is sensed. Excessive heat results from the overcurrent condition. Magnetic overload devices. Accurate means to provide overload protection. Device is not attached to the starter. Device is not affected by increased ambient temperatures. The contacts within the device will open to de-energize the motor at the desired amperage level. Restarting the motor. Motor should not be restarted immediately. Cause of the overload condition must first be located and repaired. Motor must be given ample time to cool. Many control devices are manually reset. Some controls reset automatically after a predetermined time delay. Time delay features prevent short cycling. Unit summary. Relays, contactors, and starter pass power to motors. Contacts controlled by control circuit holding coils. Relays are used for light duty. Contactors for heavy duty applications. Starters have built-in overload. Contacts on contactors and starters can be replaced. Fuses and circuit breakers to protect the entire circuit, not the individual circuit components. Motor protect can be inherent or external. So that's all for my presentation. Thank you.
So good morning, everyone. I will be discussing all about basic principles of motor controls. Motor control circuits. Motor control circuits and equipment permit the use of smaller conductors, cables, and raceways. Control equipments can also have a much lower ampere rating. Many smaller motors use the same size conductors for both control and power circuits, but, uh, but as the horsepower increases, it became impractical to do so. Mini motor control circuits are often connected to lower voltages than the motor they control to make it safer for operators and maintenance personnel. A motor control circuit, for the most part, simply a switch or a group of switches and a motor. For example, a time clock that operates a pool or sprinkler pump is nothing more than an automatic switch. At a preset time, a set of contacts open or close, turn off or on. Another example. An automatic garage door opener uses a radio signal to operate a switch that activates a garage door in much the same manner as a typical up-down push-button station. Mini motors are controlled by computerized control systems. Solid-state logic controls or programmable logic controls (PLCs). The fundamentals of control systems still apply. The PLC controls an external output based on the logic of a control program, and that output controls the motor or groups of motors by using a magnetic starter, and in some cases, additional relays. PLCs and other solid-state control devices were originally invented to provide less expensive replacements for older automated systems that use large number of relays and mechanical timers. In some cases, a single PLC can replace a thousand of relays, resulting in less expensive wiring systems that offer greater flexibility in control design. Motor control language. Electrical symbols, words, and line diagrams provide the information necessary to understand the operation of motor control circuits. Used together, they create a type of motor control language that's used to transfer information and ideas quickly and efficiently. The symbols in motor control schematic represent devices, power conductors, control conductors, conductor connections, and terminals, and sometimes the motor itself. In many cases, the symbols and words have a similarity to the items they represent. The basic type of schematic are shown in Figure 1-3, Part A, B, and C of that figure illustrate three different methods of representing same control circuit. Ladder diagrams. Ladder diagrams are also called the line diagrams or elementary diagrams. They use to represent the function of the control circuit, the association devices, but don't show the components of the control circuits in their actual positions. So here it shows the types of motor control schematics ladder diagram. Connection diagrams. Connection diagrams or wiring diagrams show the components of the control circuits in a semblance of their actual physical locations. Remember, ladder diagrams show electrical functions and wiring diagrams show the actual components. Pictorial diagrams. Pictorial diagrams are often used in educational materials and as exploded view or cut-away view in installation and maintenance literature. Pictorial diagrams help students see actual devices and components used in motor control circuits and how they relate to the symbols used in ladder diagrams and wiring diagrams. Conclusion. These units explain the basic concepts of motor controls, concentrating on how specialized electrical symbols, words, and line diagrams are used to convey information about motor control circuits. It provided an introduction to the following types of diagrams. And that's all. Thank you.
Okay, so I know you are amazed of how motor controls do its work automatically, but in electrical engineering, doing those things in engineering, like in our society, there is a standard for bases like rules and regulation, but I think it is for the safety of everybody. And I think we will learn it from our next lecture. And they will talk about the book of the standards for electrical engineering, which is the part one of the Philippine Electrical Code.
Good day, everyone. My name is Kazaya Jainanta, and together with me are Princess Jade Onesto and Nikki Humilier. We're going to present to you the part 1 of the Philippine Electrical Code, or PEC 2017 edition. The contents, its purpose to us as a future electrical engineer, and to better understand the importance of the Philippine Electrical Code. Introduction to Philippine Electrical Code. The Philippine Electrical Code is used nationally as the basis for safeguarding persons, buildings, and its contents from hazards that may arise from the use of electricity. The primary purpose of the code is to minimize the risk of electricity as a source of electric shock potential ignition source of fires and explosions. The primary objective of the code is to establish basic materials quality and electrical work standards for the for the safe use of electricity for light, heat, power, communications, signaling, and for other purposes. This code is intended as a design specification or an instruction manual for qualified persons. The electrical designs must be comply with the requirements of code to ensure safety. Compliance to the PEC will ensure safety and prevent electrical wrecks. Next. The Energy Regulatory Commission adopts the PEC Part 1 and Part 2 set by the Professional Regulation Commission as safety standards for generation companies, transmission providers, distribution utilities, and suppliers in the Philippine Grid Code or the PGC, and the Philippine Distribution Code or the PDC. Also adopted in occupational safety and health standards by the BWC DOLE as a electrical safety standard from Rule 1210 Electrical Safety. Next. Rule 1210 or the Electrical Safety. The Philippine Electrical Code is hereby adopted and the standards contained therein shall be considered safety standards. Practical safeguarding of persons and property from hazards arising from the use of electricity. The Philippine Grid or Distribution Codes, performance standards, and connection requirements are their power quality, reliability, and system laws. The Philippine Electrical Code Part 1 and Part 2 has safety standards composed of design and specifications, installation, operation, and maintenance. Okay, next. General Article 1.0. This code is intended as a design specification or an instruction manual for qualified persons. The code are now not for exclusive use of licensed electrical practitioners. It's more accessible even to non-electrical personnel. It is because safety is everybody's business. Next. Enforcement. This code is intended for mandatory application by the Office of the Building Official or EE over electrical installations. The OBO or the EE shall have the responsibility of implementing the provisions of this code. This code may require new products, constructions, or materials that may not yet be available at the time this code is adopted. In such event, the OBO or the EE may permit the use of the products, constructions, or materials that comply with the most recent previous edition of this code adopted by the National Building Code. Next. The impacts on enforcement. The Office of the Building Official are given the clear authority to implement all the provisions of the code. Needs for capacity building of the OBO, BOSH and COSH mandatory to all OBO personnel, competency training on the PEC Part 1, and last, the
New provisions are apprenticeship. Republic Act 7920 or the National Electrical Engineering Law requires apprenticeship as one of the qualifications to the registration and licensure examinations for registered master electrician or RME in order to practice electrical engineering in the Philippines. Knowledge and understanding of the PSE 1 and PSE 2 form part of the examination given. An apprentice shall undergo training under a person holding a valid certificate of registration and a valid professional license for the practice of electrical engineering under Republic Act 7920 or the National Electrical Engineering Law. Services of a licensed electrical practitioners for decisions and actions involving a knowledge of electrical engineering and or training in electrical installations and practices. The services of a licensed electrical practitioner is required. Article 1.3 Electrical Plans and Specifications. The Design Analysis. Design analysis shall be included on the drawings or shall be submitted on separate sheet of standard size and shall show branch circuits, sub-feeders, feeders, busways, and service entrance. Second, the types, rating, and trip setting of overload protective devices. Third, the calculation of short circuit current for determining the interrupting capacity of overcurrent device for residential, commercial, and industrial establishments. And fourth, the calculation of voltage drops. And fifth, the protection coordination of overcurrent protective devices. And last, arc flush hazard analysis to determine the required personal protective equipment in other than dwelling place. The impact of Article 1.3 or electrical plans and specifications. First, OBO will not accept electrical plans without technical analysis. Mandatory to all electrical plans. All electrical practitioners need to know the requirements for technical analysis. The components that create a fire or explosion. First, the fuel, flammable gas or vapors, combustible, dust, ignitable flyings or fibers. Next, the ignition source or arc spark, heat generated by equipment. And last, the oxygen, air, and other oxidizing atmospheres. In the installation rules, one element of the triangle of fire is to remove to make installation safe. Why change the PSC? A need is identified. Changes are necessary for editorial improvements, improve clarity and usability. Technical revisions, existing revisions became unsafe. New technologies and requirements, new products and equipments. Electrical safety is the deciding factor. Why changes are necessary? Hazards to persons or property. First, the fire. Next, the electric shock and property. Changes are necessary for editorial improvements. The device. A unit of an electrical system that is intended to carry or control but not utilize electric energy, which is in PSC 2009, and a unit of an electrical system that carries or controls electric energy as its principal function, which is in PSC 2017.
Why changes are necessary? Hazards to persons or property. Fire, electric shock, property. Editorial improvements, device. A unit of an electrical system that is intended to carry or control but not utilize electric energy. A unit of an electrical system that carries or controls electric energy as its principal function. The definition of device has been editorially revised for usability and clarity. The revision is intended to clarify that a device is the primary function of carrying and controlling electric energy or current. For example, this revision clarifies that a snap switch with a pilot light is devised because its principal function is to carry and control electric energy. Improve clarity and usability. Banded or bonding. The permanent joining of metallic parts to form an electrical conductive path that ensures electrical continuity and the capacity to conduct safely any current likely to be imposed. PEC 2009. Other is banded or bonding, connected to establish electrical continuity and conductivity. It is PEC 2017. Change significance. The revision provides clarity by simply describing the purpose or function of bonding. The purpose of bonding is to connect two or more conductive objects together. 2. Number 1. ensure the electrical continuity of the fault current path. Number 2, provide the capacity and ability to conduct safely any fault current likely to be imposed. And lastly, number 3, minimize potential differences between conductive components. Changes are necessary for new provision 2.10.1.8b2 GFCI protection other than dwelling PEC 2017. Commercial and institutional kitchens. For the purposes of this section, a kitchen is an area with a sink and permanent facilities for food preparation and cooking. New provision 2.10.1.8b for GFCI protection other than dwelling. Outdoor and public spaces. For the purpose of this section, is public space is defined as any space that is for use by or is accessible to the public. New provision 2.10.1.8c, boat hoists. GFCP for personnel shall be provided for outlets that supply boat hoists installed in dwelling unit location. New provision 2.10.1.8b5, GFCI protection other than dwelling. Outdoor were installed to comply with 2.10.3.14 heating, air conditioning, and refrigeration outlet. New provision outdoor receptacle for outlets for one family dwelling. New provision row housing with GFCI protected receptacles located at the front and the back of each dwelling as required by 210.52e. New technologies and requirements. Arc fault circuit interrupter. An AFCI is a device intended to open the circuit when it detects the current waveform characteristics that are unique to an arcing fault. New technologies and requirements. 2.10.1.12 arc fault circuit interrupter protection. B. Dwelling unit bedrooms. All single-phase and 15 and 20 amps branch circuits supplying outlets installed in dwelling unit bedrooms shall be protected by a listed AFCI combination type installed to provide protection of the branch circuit. Here's the AFCI. Tamper resistance receptacles. 406.12 A11, 15, and 20 amps, 230 volts, non-locking type receptacle in the following areas shall be listed. Tamper resistant receptacle. Number 1, dwelling units. Number 2, guest rooms and guest suites of hotels and motels. Number 3, child care facilities. 4, preschools and elementary education facilities. 5, business offices, corridors, waiting rooms, and the like in clinics, medical and dental offices, and outpatient facilities. 6, places of waiting transportation, gymnasiums, skating rinks, and auditoriums. And lastly, dormitories. Changes are necessary for new products and equipments. Resistant receptacles in dwelling unit, NEC 2017 406.12. Why do you think is a tamper-resistant receptacle? To increase safety for children, maybe that your son, daughter, or grandchildren that you will save. And that brings us to an end of our presentation. Thank you everyone for your time and attention.
Okay, so thank you very much to our future engineers to talk about the Philippine Electrical Code. So I think now your minds are full of electrical engineering terms. So for now, let's shift to the field of civil engineering. Let us all learn from their world how to estimate, and I hope you will enjoy learning from our next lecture and also our last lecture for today.
Today, I am tasked to discuss the basic of estimating a building. But before that, I would like to greet first our dean, professors, and to our aspiring engineering students. Good day, sir, ma'am. I am Sergeant J.V.A. Cruz, Philippine Air Force, a non-commissioned officer of the Philippine Air Force. Presently, I am assigned at Colonel Jesus William Air Base, Pasay City, at the Office of the Air Force Chief of Engineers. I am also a third-year civil engineering student at STI West Negros University. As you can see, I'm a working student, no? Okay, first, do you think it is possible to compute how many candies can fit in one jar as shown? Yes, it is possible. And that's where the estimate came from. It will be very useful, not just in estimating the number of candies in the jar. Usually kasi sa pag-estimate, we need to know first the area of the house and what materials we'll be putting and installing on that certain part of the house. Ganyan din ang concept sa paggawa ng kung ilang candies ba ang kasya sa jar na yan. Get the volume of the jar and volume of one piece of candies, assuming na pare-pareho ang volume ng candies. Next, we divide the volume of jar to the volume of candies and we have our answer na. Scope of my presentation as shown. First, what is estimate? An estimate is a calculation of the quantities of various items of work and the expenses likely to be incurred thereon. The total of these probable expenses to be incurred on the work is known as estimated cost of the work. The estimated cost of a work is a close approximation of its actual cost. So ito palang estimate is close approximation lang of its actual cost. So hindi siya sakto. Pero dapat hindi tayo kulangin. Mas mabuti nang sobra tayo kasi mahirap maghabol kapag kulang. Next, type of construction estimate. There are several kinds of estimating techniques. This can be grouped into two main categories. 1. Approximate estimates. An approximate estimate is an approximate or rough estimate prepared to obtain an approximate cost in a short time. For certain purposes, the use of such methods is justified. Justified siya kasi meron tayong factor per square meter. Short time kasi makakapagbigay tayo ng rough estimate. Remember, rough estimate, hindi siya detailed. Tanungin man tayo kung magkano ang magagasto sa area na ito, halimbawa, 100 square meter. So, ang factor natin is 30,000 per square meter. 30,000 is good for construction. So, 100 square meter times 30,000, we have 3 million pesos rough estimate. Second, detailed estimates. A detailed estimate of the cost of a project is prepared by determining the quantities and costs of everything that the contractor is required to provide and do for the satisfactory completion of the work. It is the best and most reliable form of estimate. So, sabi nga, cost of everything. So, lahat, ultimo pako, ultimo basahan, sinasama sa estimate para accurate ang ating presyo sa project. Okay, proceed na tayo sa actual estimating. Bungalow house. I believe naturo na sa inyo yung pag-AutoCAD at pag-SketchUp siguro ng plano na ito, no? As shown. So, sa plano, we have 8 meters by 8 meters na floor plan. So, ang floor area niyan is 64. Okay, dun muna tayo sa general requirements. So, start na tayo mag-estimate. Sabi ko nga kanina, total floor area, 8 meters times 8 meters is 64 square meters. So before tayo mag-start, kailangan muna natin mag-clearing and cleaning ng site. So plus 1 square meter both sides tayo kasi hindi lang naman yung actual area na tatayo na nga ayusin natin, kundi yung paligid nito. Lalo na kapag mga government projects, usually minsan may mga billboards pa yan. So plus 1 tayo both sides, so 8 plus 1 Plus 1 ulit sa kabila, so 10. Ganun din sa kabilang side. So 10 times 10 is 100 square meter. Sa layout and staking, 8 times 8 is equal to 64 square meter. So doon tayo sa actual kapag layout and staking. So ilagay natin sa Excel. So clearing and cleaning. Yan, 100 square meter times 20 is 2,000. 64 times 20 is 1,280. Next, earthworks tayo. Okay, kunin natin yung perimeter ng floor plan na as shown. I believe marunong tayong kumuha ng perimeter, no? So linear meter ito. So kunin lang natin siya. 8 times 4 plus 4 times 3 plus 2 plus 2.5 plus 2.55 plus 1. So in total, we have 52 linear meter. Ngayon, sa excavation, volume ang kailangan natin. So perimeter times depth times width. So yun nga, linear meter times 0.95 times 1. So ito is makikita natin mamaya sa lalim ng column tsaka column footing. Bakit 0.95 tsaka 1? So ngayon, focus tayo sa excavation. 49.4 cubic meter. Lagay natin sa Excel. Structural excavation kasi mga structural yung ilalagay natin doon. Yan, so kita nyo, ginawa kong 50 kasi dapat sosobra tayo. Hindi tayo kukulangin or hindi dapat tayo saktong-sakto lang. Kasi hindi naman tayo yung magtatrabaho. Hindi natin alam yung workmanship ng ating ang magtatrabaho. So, 300 pesos per cubic meter ang excavation. So, 50 times 300 is 15,000. Next, backfill and compaction. So, sa backfill and compaction, kung ano yung nakuha nating cubic meter sa excavation, times 1.25. Bakit? Kasi 25% additional for backfill tayo. Kasi ganun nga, sabi ko nga kanina, dapat sobra tayo. Lalo dito sa backfill, hindi kasi ito minsan accurate. Dapat lagi tayong susobra. So, sa ginagamit natin, 25% ang additional natin. So, 49.4 times 25% or shortcut times 1.25 is 61.75 cubic meter. Lagay natin sa Excel para makita natin ang amount. Yun, ni-round off ko ulit. Kasi nga, kailangan natin sumobra. Mas mabuti ng sobra kaysa kulangin. So, 350 pesos per cubic meter ang backfill and compaction. 350 times 62, 21,700. Next is pest control. So, pest control kasi maraming klase. So, ang ginamit ko dito is ito yung may ini-injectionan yung lupa sa paikot. So, kukunin lang natin yung perimeter na exterior walls. So, yun nga, yung labas, 8 meters, harap-likod, kabilaan. So, 8 times 4 is 32 linear meters. So, lagay natin sa Excel para magkaroon tayo ng amount. Okay. 62 pesos per cubic, square meter to. 60 pesos per square meter ang pest control. So, we have 1,920. So, linear meter pa. So, total sa earthworks, meron tayong 38,620 pesos. Next, formworks tayo. So, ano nga ba itong formworks? Siyempre, kailangan natin ng forma before tayo magbuhos. Ito yung mga requirements. Hindi ka naman makakabuo ng rectangular kung wala kang forma, kung magbubuhos tayo ng semento. So, ito ang kailangan natin. Ito ang formula. Actually, based ito sa estimate ni Max Fajardo. So, perimeter equals 2 times A plus B plus 0.20. Ano yung A plus B? Yung A, ito yung shorter side ng column. Yung B naman, ito yung longer side. 0.20 is constant. So, ang column natin, nakikita mamaya, ang shorter side is 0.25 meters plus 0.30 meters ang longer side. Apply lang natin yung formula. Plus 0.20 is equal to 1.3 meters. Okay, nakuha natin ang perimeter. Kunin natin yung total area. perimeter times height of columns times number of columns. So yun nga, perimeter 1.3 meters times 3.80. Ano nga ba to? Ito yung height ng columns. So actually, yung from finished floor line, 3 meters ang height niya hanggang ceiling. Yung 0.80, ito yung nakabaon sa ilalim. Then we have 9 columns. So tingnan natin yung floor plan. Okay. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 columns. Kaya sinama natin siya doon. So total natin is 44.46 square meter. So proceed na tayo sa number of plywood board. Nakuha nating total area, divide lang natin sa 2.88. Ano nga ba itong 2.88? Ito po yung area ng phenolic board or yung mga plywood or board na nabibili sa market. So 4 feet by 8 feet ang nabibili. So kunin natin yung area nun, 2.88. Divide lang natin sa total area nung 44.46. So meron na tayong 15.43. Wala naman tayong mabibiling 15.43 sa market. So buuan yan. So i-run off natin siya ng 16 pieces of 1/4 inch thickness. Ito yung thickness niya. So 4 feet by 8 feet phenolic board. So ilagay na natin sa Excel. Okay, so we have 16 pieces, 600 pesos ang isa. So 16 times 600 is 9,600 pesos. Next, sa 2x2 wood frame tayo. So dun nga sa book ni Max Fajardo, ang constant natin sa pagkuha ng framing gamit ang 2x2 is 29.67 times 16 or times doon sa number of plywood or board. In case ginamit ko is phenolic board kasi ito yung ginagamit na natin ngayon. Actually pala, yung formworks, pwede nating magamit ito up to 3 uses. Balik tayo sa wood frame. 29.67 times 16. Meron tayong 474.72 board foot. Tingnan natin sa Excel. Okay, 475 per board foot. Ang 50 pesos ang per board foot. So times lang natin 23,750. Next is nails. So constant 0.08, correct? 44.46 square meter yung nakuha nating area kanina. Total area ito. So kapag tinimes natin 3.55, bakit may plus 1 ako? Kasi usually sa experience ko sa site, laging kulang ang pako. Yun nga, depende sa workmanship ng tao, yung trabahador. Kung paano siya magtrabaho. So nagdadagdag talaga tayo para hindi kulangin. So 3.55 plus 1 is 4.55. Wala naman mo yung biling 4.55. I-round up na natin ng 5 kilograms. So ilagay natin sa Excel. Okay, 5 kilos. 80 pesos ang per kilo ng pako. So we have 400 pesos. So yun nga, no? Up to 3 uses ang ating mga phenolic board. Actually, kung mas magagaling ang nagtatrabaho, magandang workmanship, pwede pa nga itong gawing mga temporary table. So magagamit pa natin ito sa ibang bagay. Basta magaling ang karpentero natin. Next. Okay. So itong nakakita nyo ay ito ang tinatawag na column footing. So ito yung nasa pinakailalim. Ito yung pinakapaa ng bahay. Ito yung pinaka-pundasyon na talaga. Okay, complete works na tayo. Column footing. Una, kailangan natin makuha ang volume. Length times width times thickness. So ang length, nung pinakita kong column footing kanina ay 1 meter. 1 meter ito by 1 meter. Ang thickness niya ay 0.15. So times lang natin para makuha ang volume. We have 0.15 cubic meter. So isang column footing lang yon. So ang total volume, times natin sa 9 column footing. Actually, ang ano pala sa column footing, ang abbreviation niya is CF. Ito na yung madalas na nakikita sa plano. 0.15 times 9 is 1.35 cubic meter. Ito yung total volume. So, ang gagamitin natin para sa concrete mix is class A. Ang timpla pala nito or ang ratio nito is 1:2:4. Ano bang ibig sabihin itong 1:2:4? Ibig sabihin, isang parte ng semento, 2 parte ng sand, at 4 na parte ng gravel. Sa site kasi may measuring box tayo. 0.30 by 0.30, bali 1 cubic meter yung measuring box. Yun ang ginagamit natin sa site. So, ang formula natin is volume, yung 1.35, plus yung constant of class A. So, ano ba yung constant? Ito yung 9, 0.5, and 1 pagdating sa class A. Based din ito sa book ni Max Fardo. So, cement, 1.35 times 9 is 12.15. Say 13 bags kasi wala namang bibiling 12.15. Next is 1.35 times 0.5, 0.67. So, round off natin, 0.70. Gravel is 1.35 times 1, 1.35. Say, 1.50 cubic meter. So, lagay natin sa Excel. Yan, ang semento natin is 230 pesos per bags. So, 13 times 230 is 290. 400 naman sa sand. Then sa gravel ay 1,100. Bali, ang presyo pala nito depende sa lugar, no? So, ito ang ginamit kong pricing dito is sa Manila. Ito to sa Bacolod kung same ang price. So, magbabari yan sa lugar. Merong mahal sa Manila, mura sa Bacolod. Merong mahal sa Bacolod, mura sa Manila. Depende kasi sa supplier kung malapit. Next is rebars tayo doon sa column footing. So, ang spec natin doon sa column footing is 5 na 12 mm diameter both ways. So, ibig sabihin, may tagli-5 bakal siya kabilaan. 12 mm ang ginamit natin dito. Para makuha ang rebars, number of bars both ways times length. So, kasi nga kabilaan, kaya magiging 10 siya. 10 times 1 plus 0.05. Yun nga, yung length niya kanina ng column footing is 1 meters. Ano ba itong 0.05? Ito yung clear cover for footing, kaya dinagdag natin siya. So, we have 10.5. 9 units ang column footing natin. So, times natin siya sa 9 ulit. We have 94.5 linear meter. Ito yung total na haba ng bakal na kailangan natin sa column footing. Pero, wala namang mabibiling 94.5 metro na bakal. Ang nabibili natin sa market ay 6 meters. Putol-putol. So, kailangan natin siyang i-divide sa 6. So, ito na nga. Number of 6 meter of bars equals 94.5 divided by 6. 15.75 siya. Wala namang mabibiling 15.75. So, round off tayo. 16 pieces of 12 mm diameter bars. Input natin ulit sa Excel. Okay, 210 pesos per piraso ang 12 mm diameter bars natin, no? Proceed tayo sa tie wires. Ano ba tong tie wires na to? Ito yung parang, di ba may intersection siya? Kasi magtatamaan ng bakal eh. So ito yung parang nagiging sinulid niya, yung nag-hold kada intersection para hindi siya maghiwa-hiwalay. Napaka-importante nito, lalo sa structural, kasi dito rin halos mag-base ang strength ng ating mga pundasyon. Kung wala ito, medyo magagalawan ng ating mga bakal kapag nagbuhos. So, ang formula is number of bars, vertical times horizontal, times number of column footing times 0.4, which is constant, divided by 53. Ano tong 53? Itong 53 ay, ito ang haba ng total tie wires kapag bumili ka ng 1 kilo. Bali, 53 meters ang haba. So, substitute natin mga values, 5 times 5 times 9 times 0.4 divided by 53. We have 1.69. Say, 2 kilos of tie wires. Okay, natin ulit sa Excel. Okay. Tapos na tayo sa column footing. Pupusin tayo sa column. Okay. As shown, ito yung column or poste na tinatawag. Ito na yung usually na nakikita natin kapag may nagko-construct ng building. Yung column footing kanina, which is etong nasa baba, hindi na natin usually nakikita ito. Kaya akala natin yung poste lang ang meron, pero meron pa pala sa baba ng building. Bali, ito ang column. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 columns like the column footing. Okay, so ulit tayo sa pagkuha ng volume ng column. Ganun ulit. Length times width times height. 0.25 yung length, 0.30 ang width, ay ng height niya is 3.80. Ito yan siya. Total nito, hanggang dito sa baba is 3.80 to. Then yung width nito ay 0.25 by 0.30. Yan, ito yan siya. Hindi ko na nilagay ang specs kasi baka maguluhan doon sa pag-drawing, no? So, i-discuss ko na lang. Yan, so we have 0.285 cubic meter. Yun ang volume ng isang column lang yan. So, we have 9 columns. So, times lang natin sa 9, yung 0.285, we have 2.57 cubic meter. So, using class A tayo. Kasi maraming class na ginagamit sa concrete. May AA, may A, may B, may C. Pero bakit A? Kasi structural to. Kailangan natin matibay yung pundasyon. Itong class A kasi nagre-range ito ng 3,500 to 4,000 PSI, which is the requirement sa ating structural. Na-discuss ko na kanina kung ano yung mix niya. So ganun ulit, times lang natin, 2.57 times 9. We have 23.13, say 24 bags. Cubic meter times 0.5, 1.28, say 1.5. 2.57 times 1, 2.57, say 3 cubic meter. So, ilagay natin sa Excel. Yun, 230 pesos. 400, ito na-discuss ko na kanina. I-times lang natin para makuha natin ang total price. Okay, sa reverse tayo. So, pansin nyo, lagi na tayong ma-reverse. Kailangan yan kasi ito yung talagang magiging buto ng ating structural. Although matibay na ang ating buhos, pero hindi ito kakayanin. Lalo na kung may mga live load na sa mga building, baka bumigay. So, kailangan talaga may reverse. Mas malakas ang magiging structural dito, capacity. So, ganun ulit, number of bars, both waist times length. So, doon sa plano, we have, pakita ko lang, we have 4, 4 na bakal to, nakatayo. Usually, yan ang nakikita natin. Tapos, yung height nga, yung kanina, yung length, which is ito yung height, 3.80. So, 15.20 times 9. Ito yung 9 units of column. Bali, lagi lang natin siyang ita-times sa 9 kasi para accurate tayo, ito yung number of columns na meron tayo. Total, 136.80. Yun nga, wala namang mabibiling 136 na haba. So, divide natin ulit sa 6. We have 22.8, say 23 pieces of 12 mm diameter bars. I-input natin ulit sa Excel. Okay, so 210, as discussed earlier, times lang natin, we have 4,834 12 mm diameter deformed bars. Next is ties. Ano ba tong ties? Ito yung umiikot doon sa column natin. Ito yung nag-hold sa 4 na bakal. Pakita ko lang ulit. Ito yan siya, yung maliliit na pie square. Kung nakikita nyo, yan yung ties na umiikot sa poste. Bali horizontal siya. Yung 4 kanina, yun yung vertical bars. Okay, so kunin muna natin yung length meter of 1 ties. So yun nga kasi ang length at width natin ng column ay 0.25 times 2 kasi kabilaan. Then 0.30 times 2 din kabilaan kasi plus 0.05. ito yung pasobra. Hindi naman pwedeng sakto lang. Kailangan may sobra tayo doon sa ties natin. Kundi mag-i-slide siya. So total ng isang ties natin ay 1.15 linear meter. So sa specs, ang sabi is 5 at 0.10 meters. So times lang natin siya. Meron tayong 5 bakal sa 0.10 meters. So 5 times 0.10, meron tayong 0.50 meters ang na-occupy natin. 5 bakal every 0.10 meters. Ang isa pang specs ang sinasabi, rest at 0.15 meters. So i-minus lang natin to. Kunin muna natin yung height kanina, which is 3.80 minus 0.50. So may remaining tayo na 3.3. However, ito may sinasabing rest at 0.15. 3.3 divided by 0.15, meron tayong 22 pieces na set ng ties. Plus 5 tayo kasi sabi nga kanina, 5 set every 0.10. So 22 plus 5 is equal to 27 pieces of ties in one column lang yan. Okay, sa ties, yun nga, 27 pieces of ties in one column. Kunin natin yung number ng bakal in 6 meters, no? So, ito, shortcut ko na, pieces of ties times linear meter of 1 ties times 9 units of column. Laging times 9 tayo kasi siya yung column natin. So, 27 pieces, ito siya, times 1.15, ito yung length ng 1 ties, times 9. Divided by 6. We have 46.58. So, 6 kasi nga, yun nga yung ano ng bakal, yung haba. Kaya laging 6 ang kanyang constant dyan. Ilagay natin ulit sa Excel. Okay, so we have 47 pieces. So, mas mura to kasi mas maliit ang diameter. 150 pesos lang siya. 150 times 47 is 7,050 pesos. Next is tie wires. So, yun nga, tie wires, kailangan lagi natin yan. Yan yung alambre na pang kapit doon sa mga intersections niya, no? So, ang formula dito is number of stirrups. Actually, ties ito, hindi stirrups. Number of ties, kasi stirrups, sabihin ginagamit ito eh. Times 4, times 0.3, times number of column. So, 27, ito yung 27 pieces of ties, one column. Times 4, which is constant, and times 0.3, which is constant, times 9, so ito yung number of columns. Divided by 53 ulit, which is the total length of 1 kilo tie wire. So we have 5.50, say 6 kilos of tie wires. Lagay natin sa Excel. So 85 pesos, we have 510. Okay, kasi tayo sa wall footing. Ito yung, as shown, ito yung wall footing. Ito yung nag-hold sa poste sa baba. Paikot mo yan. Parang ito yung biga sa baba. Umiikot. Ito yung nag-hold sa structure para hindi magiwa-hiwalay. Napaka-importante nito, lalo sa earthquake. Dapat matibay din to. So, ganoon din ulit. Wall footing, volume. So, perimeter, as kanina na na-discuss ko, ang perimeter natin paikot, ang buong building is 52. Times lang natin yung width niya. So, sa plano is 0.45 siya, times 0.20. Pag nabuha na natin, yung total volume na pala ito kasi perimeter 90 times natin, which is 52. So, total volume is 4.68 cubic meter. Using class A ulit, kasi nga structural, apply lang natin yung mga constants. So, apply ang i-times natin ang constant sa total volume. So, sa cement, we have 43 bags. Sa sand, 3 cubic meter. Sa gravel, we have 5 cubic meter. Ilagay natin sa Excel. Same price. Okay, sa cement, we have 9,800. Sa sand, 1,200. Gravel, 5,500. Okay, sa rebars naman tayo ng wall footing. So, sa specs, ang sinasabi ay 3 10 mm diameter bars with 10 mm at 0.30 crossbars. So ito, ibig sabihin may tatlong bakal siya sa buong perimeter niya. So kunin natin ang haba nito. Kung gaano siya haba. Number of bars times perimeter. 3 times 59, we have total 177 linear meter. Additionally, meron tayong crossbars. So ito yung nasa baba. Ito nasa taas to. Itong tatlong bakal na ito. Then meron siyang crossbars sa baba na nag-hold. So 59 divided by 0.30 equals to 196.66 times 0.45, which is ito yung length, equals 88.50 linear meters. So meron tayong total linear meters sa crossbars and rebars na 177 linear meters. So 177 plus 88 is equals to 165.50 linear meter. Ito yung total na haba na bakal, total length ng bakal na kailangan natin. Wala naman siya mabibili. So divide lang natin sa 6. And we have 28 pieces of 10 mm diameter bars. Lagay natin sa Excel. So 150 pesos kada piraso. So 4,200 ang isa. Next is the tie wires. Ang formula is number of crossbars times 4 times 0.3. So ang crossbars natin, ang number niya ay 197. Ni-round off ko na siya kasi 96.66 siya. Times 4, which is constant, and times 0.3, which is constant, divided by 53 ulit, we have 5 kilos of tie wires. Okay natin sa Excel. So 85 ang isa, we have 425 pesos. Next is slab. Okay. Asyon, ano ba ang slab? Ito yung flooring na tinatapakan natin, no? Bali sa old school kasi ang ginagamit natin yung mga kahoy pa eh. Yan yung mga luma na inaanay talaga. Especially wala pang pest control dati. Pero itong slab is buhos na ito na may reinforcement na. Much better na siya kasi pwede natin siyang i-tiles. Mas maganda ang finish. So ganun ulit. Kunin natin ang volume. So length times width. Ito yung kita natin sa floor plan. Yan, 8 times 8. Kunin lang natin yung total floor area. 8 times 8 is 64 square meter. Times 0.10 ito actually. Kaya 6.4 cubic meter siya. Kasi ang thickness ng slab is 0.10 lang. 10 mm is or 0.10 meters. Total volume is 4.68 cubic meter. Check natin. Bali 6.4 nga siya. Supposedly ito ay 0.10. And this is 6.4. So mali na input. Okay, so nakuha natin ang total volume, 6.4 cubic meter. Times lang natin siya sa constant na Class A concrete mix. So sa cement, we have 58 bags. Sa sand, meron tayong 3.5 cubic meter. And sa gravel, meron tayong 6.5 cubic meter. Ilagay lang natin sa Excel. 8 bags, 230 pesos. Same pricing pa rin. Actually, iba ang bars natin dito. This is a temperature bars. Bali, resistant ito sa shrinkage, no? Sa mga stresses kasi kailangan matibay dapat siya. Actually, in the future, kung balak nyo mag-civil talaga, maraming stress kayong i-handle sa pag-discuss, lalo na kapag nasa mga major subjects na kayo. So, yun ang ibig sabihin ng temp bars or temperature bars. Shrinkage resistant siya. Then rebars for the slab. So 10 mm diameter at 0.50 meters on center both ways. So ito yung specs ng rebars natin. So divide natin ang isang side. 8 divided by 0.5, meron tayong 16 sets ng bakal. Times 2 natin kasi sa kabila, ganun din, sa isang side. So, 32 sets times 16 is equals to 512 linear meter. Yan yung haba ng bakal na kailangan natin. So, number of 6 meter bars is equals to 512 divided by 6, 85.33. Say 86 pieces of 10 mm diameter temperature bars. Ilagay lang natin sa Excel. Okay, ito siya. 86. Na-discuss ko na kanina. 150 pesos ang isa. So, sa time wires tayo, number of intersections times 4 times 0.3 long ties divided by 53. So, 16 horizontal times 16 vertical times 4 times 0.3. Ito, times natin, makukuha natin yung intersection. So, we have 6 kilos of tie wires. Lagyan natin sa Excel. Proceed tayo sa beam. Okay, assume ito yung beam, yung parang footing siya pero sa taas nga lang siya, which is nag-hold din sa column natin, paikot din yan siya. So dito, ang isang set ng beam natin is 4 meters kasi column to column. So isang set na ng beam yan. Okay, kunin natin ang perimeter ng beam, which is 8 times 5 is equals to 40 linear meter. So we have haba na 8 na beam and 5 sets nito. So same lang din naman kung 4 meters times 10 lang natin siya. So 40 linear meter pa rin. So volume, perimeter times width times thickness. 40 linear meter times 0.36 times 0.20. Ito yung nasa plano natin na width and thickness. So kuha natin ang 2.88 cubic meter. So ganun ulit, apply ang constant. For class A, which is sa cement, we have 26 bags. Sa sand, we have 1.5 cubic meter. Sa gravel, we have 3 cubic meter. Lagyan natin sa Excel. 230, 5,980 na sand. 1.5, which is 600 pesos. 3 cubic meter, 1,100. Proceed tayo sa rebars. So sabi sa specs and sa plano at support, 3 bakal, 12 mm diameter top and 2 na 12 mm diameters bottom, 1 meters both sides. So sabi ko nga kanina, yung isang beam is 4 meters. So 1 meters both side kasi may midspan tayo. So ito ang design sa malapit sa column. 1 meter siya away from column. So at midspan is 2 12 mm diameters and 3 12 mm diameters bottom, 2 meters midspan. So may dalawang bakal, diameters tayo, sa taas yan. Then sa bottom naman, meron tayong 3 bakal na 12 mm. Bali ang midspan natin is 2 meters. So total nito is 2 plus 2, which is ito kabilaan, kaya ng 2, 4 meters. So isang beam na ito. So substitute natin ang mga values. So sa support muna tayo, 5 bars times 2 meters, both side kasi, times 10 beams kasi 4 meters, isang set ng beam, may 10 beams tayo. Kung 8 naman, 5 lang. Pero in this case, ang design kasi natin is column to column, kaya 4 meters ang isang set ng beam natin. So we have 100 linear meter in support. Sa midspan naman, 5 bars times 2 meter kasi midspan, times 10 beams, 100 linear meters din. So add lang natin, we have total linear meter of 200 linear meter. Divide lang natin sa 6 para sa bakal niya, 34 na 12 mm diameter bars. Lagay lang natin sa Excel. Okay, so 210 times 34 is 7,140. Pansin nyo, lagi tayo nagra-run off pataas, hindi tayo pababa kasi kailangan hindi tayo magkulang sa estimate. So stirrups, ito yung kanina na nasabi ko. So parang ties din siya. sa column. Pero itong stirrups ito ang term na ginagamit natin sa beams. Ito yung humahawak doon sa mga bakal na nasa loob ng beam. Sabi, sa specs, we have 1 at 0.05, 4 at 0.10, and 6, 0.20 meters, and rest at 0.25 meters. Based on plans, we have 23 sets of ties in one beam. 23 times 10 sets of beam is 230 sets. So, doon sa beam, sa ties natin, based sa plano, meron tayong 23 sets ng ties. And meron tayong 10 sets ng beam, which is, ang isang set is 4 meters. So, 23 times 10 is 230 sets ng ties ang meron tayo. Para makuha natin ang haba nito, kunin natin ang isang haba ng ties. So, yun nga, yung width and length at thickness tayo ng beam. Balik tayo, 0.36 times 2, kabilaan. 0.20 times 2, kabilaan ng beam. So, 1.12 plus 0.05 equals 1.17 linear meters. 230 sets times natin sa isang haba ng 1 ties. 230 times 1.17 is 269.10 linear meters. So, divide natin sa 6 ulit kasi wala naman mabibiling 269.10 na haba. So, dividing by 6, we have 45 pieces, rounding off na ito sa 44.85. 45 na 10 mm diameter bars, which is ito yung stirrups natin. Ilagay natin sa Excel. 45 pieces, so 150 pesos ang 10 mm. Kagaya ng mga ibang bakal natin. So, sa tie wires tayo. Ito rin yung nag-hold din na parang sinulit sa kada intersections. So, 230 na number of set of ties. Ito yung 230. Ito yan siya. May 230 sets tayo. So, times natin yung mga constant, times 4, times 0.3 divided by 53. We have 6 kilos of tie wires. Lagay natin sa Excel. So, we have 510 pesos para sa tie wires. Okay, so tapos na tayo sa concreting works, which is the majority naman yan is foundation, no? So yung CHP is i-discuss na ating isang kasamahan. So i-skip ko na yon, diretso ko sa tiling works na, assuming na may CHP na tayo before tayo mag-tile works. Ito more on finishing na. Kailangan natin muna makuha yung total floor area. So yun nga, 8 times 8, yun na yung total floor area niya, which is 64 square meter. Toilet and bath area. Ito yung 1.5. Ito pala yung toilet and bath. 1.5 times 2.5 is we have 3.83 square meter. Ngayon, ililis natin yung total floor area at toilet and bath. Bakit? Kasi ibang tiles ang ginagamit sa toilet and bath. Hindi ito pareho sa mga ginagamit natin sa ating mga living room, dining, o hallways. So, less natin, 64 minus 3.83. So, ang total floor area na ating lalagyan ng synthetic granite tiles, usually yan ang ginagamit natin sa mga living room. 60.17 square meter lang. So, using 0.60 meters times 0.60 meters tiles, ang area ng isang tiles na ito is 0.36 square meter. So, divide lang natin yung 60.17, which is less na dito, yung toilet bath area. Divided by 0.36, we have 167.13 times 1.05. 5% wastage. Kailangan to kasi most of the time, yun nga, depende sa workers. Minsan kukulangin pa nga ito, lalo kung pabaya, maraming nababasag na tiles. Hindi tayo pwede magsaktong 167 or 68 lang. Kung may mabasag, nagpagawa ka ngayon ng tiles, ibang kulay na. So, ang pangit tingnan. Maganda, may sobra tayo na same color siya. Para kapag natapos yung project, magandang kulay. Isang kulay ang nakikita natin sa flooring. So, yun nga, 167 times 1.05 is equals to 176 pieces. Lagyan natin sa Excel. 300 synthetic. 176 times 180. 180 pa lang isa nito, no? Kasi synthetic lang naman siya. Kaya mura. Pero kung granite tiles, so medyo mahal-mahal na yan. Dito lang tayo sa mura. 176 times 180, 31,000. Pansinin nyo pala, inilalagay ko yung mga area kada works. Kasi ito para ma-double check natin at kapag nag-check tayo on-site, alam natin kung gaano kalaki, kalalim ang i-installan natin ng mga gamit at mga materyales, no? So, dito ito naman using 0.30 times 0.30 tiles. Ito ay ginagamit. Ito ang gagamitin natin sa toilet and bath. Equals to 0.09 square meter ang isang tile. 3.83. Ito yun siya. Toilet and bath area to. Divided by 0.09, we have 42.55. Again, times 1.05. 5% wastage. Meron tayong 45 pieces na 0.30 by 0.30. Put natin sa Excel. So, nilagay ko dito is non-slip ceramic tiles kasi kailangan hindi madulas yung tiles natin. Hindi magkukos pa ito ng accident. Malaki ang magagastos natin. So, 45 times 70 is 3,150. Okay. So, sa tiling, hindi lang naman bumili tayo ng tiles. Yun na yun. So, kailangan natin ng mga pandikit para kumapit ito sa ating flooring. So, ito na nga yung isa-isang tile adhesive. So, ang constant niya is 0.11 bags per square meter. Ibig sabihin, ang kaya niyang installan is 0.11 bags per square meter. So, 64 times lang natin ang total floor area, which is 64. Isama na natin yung CR kasi pareho lang naman yan installan ng adhesive. So, 64 times 0.11, we have 7.04, say 8 bags. So, pataas tayo ulit, hindi tayo bababa. Cement mortar, ang constant niya is 0.086 bags per square meter. Times lang ulit natin, we have 5.50 or 6 bags. Tile grout naman is 0.25 ang constant. So we have 16 bags. Put lang natin sa Excel. Eight times 300 is 2,400. Cement mortar is 6 times 250 is 1.5. Tile grout naman natin is 85 per bag. Bali 2 kilos na yung isang bag niyan. So total, we have 4,090 sa tiling. Sa concreting pala kanina, we have total of 111,000. Ito talaga yung pinakamalaki kapag nagko-construct tayo ng building. Ito yung pinakamalaking nagagastos kasi ito na talaga yung pinakabuto ng bahay natin. Proceed tayo sa ceiling works. So, ceiling works, for the basic lang, kunin lang natin yung floor area, 64 square meter. So, lagay na natin ito sa Excel. So, 64 square meter, ang ginagamit namin na constant is 600 pesos per square meter. Bali, kompleto na ito. Fiber cement board ang ini-install natin with metal paring na. Ito yung may metal tracks na, may wall angle, suspension rod, at complete accessories na. So mostly, hindi naman tayo kukulangin kapag itong i-apply natin. No? So times lang natin. 600 times 64 is 38,400 pesos. Then sa ceiling, we have a total of 38,400. Last is roofing works. Assuming natapos na tayo, may mga trusses na tayo, so ito na yung next na gagawin natin. Total floor area, which is 64 square meter. Plus 0.60 allowance both side. Bakit may allowance tayo? Kasi yung bubong may allowance yan, hindi naman natin pwedeng isakto lang doon sa wall. Lalagpas natin para hindi rin naman agad mabasa ng ulan yung mga papasok sa bahay, kaya hindi agad mabasa yung harap ng bahay. No? So i-add lang natin 8 plus 0.60 plus 0.60 both sides, ganun din. Sa kabilang side, add lang natin 0.60 plus 0.60, we have 84.64 square meter. Ilagay lang natin ang area constant. Bali dito, 950 pesos per square meter ako. Yung ginagamit naming factor. Bali ito, kompleto na siya. GA number 24. Ano ba ibig sabihin ng GA number 24? Ito yung thickness Ito yung numbering nila pagdating sa bubong. Pre-painted long span beige color. Bali pre-painted na ito, no? May kulay na itong long span na ito. Meron na rin siyang gutter, may flashing na rin, at may roof framing na. Sama yung parlina, sagrad, cross bracing, insulator, meron na rin yan. And other accessories like yung text screws, blind rivets, and bulka seal. So sa 950 per square meter, almost package na talaga siya kapag nagpagawa tayo. So dito na tayo sa recap. From general requirements, nandito siya sa baba. Kasi wala naman siyang labor cost. Mostly ano lang naman to, mga materials lang naman. So i-add natin ang earthworks, which is 38,620. Formworks, 33,750. Concrete works, 111,055. Tiling, 40,090. Ceiling, 38,400. Roofing is 80,408. So, total material cost natin is 342,323. However, material cost lang yan. Hindi pa yan yung exact natin na amount na kailangan. Itong ginamit kong factor dito na labor cost is mababa pa ito. 28%. So ito for the purposes ng total project cost, ipakita ko na lang na 28% of total material cost, yan yung labor cost. So, bukod yung pagbayad natin sa mga trabahador at pagbili ng materyales. So i-add natin yung general requirements. We have 441,453. Then contingency. Ano ba itong contingency? So 5%, ito yung mga hindi natin ina-expect na nagkulang tayo, kailangan pang bumili. So ito yung parang backup na money natin na 22,000. So lagi ito dapat kasama sa pag-estimate natin. So add natin ang TDC, which is total direct cost, 22,000 plus total project cost, 463,000. Say we have 464,000 in terms lang ng na-discuss ko. Earthworks, formworks, concrete, tiling, ceiling, roofing, and general requirements. So bukod pa yung CHB tsaka painting, which is i-discuss ng isa kong kasama dito sa costing na ito. So for the purpose nga ng estimating, ang in-apply ko na lang ay yung basic na labor cost sa contingency. So kung mag-a-apply tayo ng by contract ng mga projects, mas marami pa tayong ina-add dito ng mga factors like admin and supervision, architectural, VAT, and tax. So marami. So itong 464, kung ibabay contract natin to, is malaki pa. Which is aabot pa to ng more or less mga 700,000 kapag nag-buy contract tayo. Ito is, ibig sabihin nito, may capability ang isang lugar na mag-proceed sa kanyang construction. So may mga tao siya, may mga equipment, and mismo siya, bihasa siya, kaya ito yung ginamit nating format for the purpose lang ng pag-estimate. So yun lang, I hope na may natutunan kayo, and sana sa mga magte-take ng civil engineering, magamit nyo ito, pati yung pag-AutoCAD at SketchUp. Kasi sa real world natin, ito yung gamit na gamit talaga, especially yung AutoCAD, SketchUp, at Estimate. Kung marunong ka na nitong tatlo na to, sa akin, kung magaling ka ng dumiskarte, di ka na mawawala ng trabaho eh. Ang dami dyan na nagpapagawa ng mga bahay, papagawa ng drawing, design. Eh, doon pa lang babayaran ka na. Eh, how much more kung mag-estimate ka pa. And how much more pa kung ikaw mismo yung magko-construct ng bahay. So, doble-doble na yung kita mo dyan. So, yun lang. Maraming salamat. Sana may natutunan tayo. Thank you.
So para malaman natin kung ilang pintura ba ang magagamit natin sa isang bahay, bago yan, kailangan natin alamin ang iba't ibang uri ng pintura. So meron itong base coat at finish coat. Sa base coat, meron tayong ginagamit na primer. Primer should be used on bare and coated surface to protect the material and create a uniform, flat, smooth surface for the next coat. Sa finish coats naman, meron tayong flat, eggshell, gloss, and satin. So, para malaman natin kung ilang galong pintura ba ang kailangan natin, In 25 square meter, meron tayong 1 gallon. The number of gallons is equals to the area divided by 25. So, alamin natin kung ilang galong pintura ba ang kailangan natin sa bahay na ito. So, magsimula tayo dito sa gilid. So, meron itong area na 3.65 meter by 3 meter. Itakla natin yung hindi kasali na 1.2 meter by 0.6 meter. So, meron itong area na 10.23. Divide by 25, meron itong 0.1492 gallons. Dito naman sa kabila, meron tayong area na 3.65 meter by 3 meter. Ang area nito ay 10.95. Divide by 25, meron itong 0.438 gallons. Ito na yung manakapit nating mga galon. So, i-add lang natin lahat yan para malaman natin kung ilang galon ba lahat ang gamitin natin. So, sa kabuuan, meron tayong 5.3172 gallons or 20 liters and 128 ml. Sa base coat, dalawang gagamitin natin dahil sa inside at sa outside. So, times 2 lang ito, magiging 10.6344 gallons or 40 liters and 256 ml. Sa finish coat naman, dalawa ulit dahil sa labas at sa loob at times 2 dahil dalawang coating ang gamitin natin. So, meron itong 21.2688 gallons or 80 liters and 511 ml. So, ano pang pintura ang gagamitin natin? So, the most important deciding factors when choosing a paint are surface material and kung inside ba ito or outside. So, different materials are bond better with different paints. So, yun na kasimple kung paano malaman kung ilang galong pintura ba ang gagamitin sa isang bahay.
So, para malaman natin kung ilang hollow blocks ba ang gagamitin natin sa isang bahay, kailangan muna natin malaman ang area ng bawat isa. So, ang standard na sukat natin dito ay merong habang 0.4 meter at may taas na 0.2 meter. Nagkakaiba lang sila sa kapal. Meron itong 4 inches, 5 inches, at 6 inches. O tinatawag nating 4, 5, at 6. The number of hollow blocks is equals to the area of wall divided by the area of hollow blocks. So, for example, meron tayong itong taas na 1 meter at may habang 1 meter. Para malaman natin kung ilang hollow blocks ba ang kailangan natin sa area na ito. So, the number of hollow blocks is equals to 1 meter times 1 meter divided by 0.2 meter times 0.4 meter is equals to 12.5. So, meron palang 12.5 na hollow blocks sa isang 1 square meter. So, i-replace na natin yung equation natin. So, the number of hollow blocks equals to the area times 12.5. Ito yung gagamitin natin para mas madali nating malaman kung ilang hollow blocks ba ang gagamitin natin. So, for example, gagamitin natin yung formula na yun sa bahay na ito. Dito tayo magsimula. Meron itong taas na 3 meter at may habang 6.65 meter. So, at i-minus na natin yung butas. So, 1.2 times 0.6 equals to 10.23 times 12.5 equals to 127.875 or approximately 128 na hollow blocks ang mga gamit natin. Dito naman tayo sa kabila. Meron itong habang 3.65 meter at may taas na 3 meter. So, meron itong area na 10.95 times 12.5, meron tayong 136.875 or approximately 137 na hollow blocks ang mga gamit.
So, meron tayong 110, 119, 96, 119, 128, 137, 115, 137, 35, 130, 90, 139, 130, at dalawang 90.
So, sa kabuuan, meron tayong 1,665 na hollow blocks ang mga gamit natin. So, yun yung paraan kung paano natin malalaman kung ilang hollow blocks ba ang kailangan natin.